Okay, so guys, I want to go over the homework first. Now, the homework from yesterday, all right, you watched the video and you went along with that to answer your questions. Now, for that, all right, so we should have a pretty good understanding with this already, so I'm going to kind of move through this rather quickly. All right, neutral atoms have the same number of protons and electrons. Protons positive, electrons negative. Only electrons move. Get that through your head, okay? Only electrons move to create any kind of unbalance in charges. When atoms lose electrons, they become positive charge. If they gain it, become negatively charged. Like charges repel, opposites attract. Also, a positive and a negative, both of those can attract a neutral object. Friction can cause a charge separation. Electrons are stripped from one material and added to another, depending upon their affinity for the electron. All right, how long or how strong they have of a hold on them, which has to deal with the electrostatic series, which we'll talk about in a second. Static electricity, electric charges that can be confined to an object. We can call it, quote unquote, electricity at rest. Rubber material of a balloon has a greater attraction for electrons than they do hair. So if you rubbed a balloon against your hair, the balloons are going to rip some electrons off of your hair and become a negative charge. Your hair would therefore become a positive charge, and then your hair would kind of like stand up a little bit because like charges repel. If you were to take a positively charged acetate balloon, a positively charged acetate tube or rod here and move it towards that balloon, okay, opposites cause there to be an attractive force there. If you were to rub a paper towel on this tube and know that the tube had become positively charged, therefore the paper towel would have a greater attraction for electrons and become a negatively charged object. And then we kind of get down into this. All right. These guys tend to lose electrons. These guys tend to gain electrons. Now, basically, yeah, the higher on the list you go, you're going to wind up, you don't have a very strong hold on electrons, so you're going to wind up giving them up, all right, if you're rubbed against any object lower on this list than you. Anything higher, you're going to wind up losing them. Bottom, lower, gain them. So rubber and cotton. Rubber is here, and cotton is here. Cotton is or rubber is lower, so he's going to attract the electrons and become negatively charged. Silk and nylon. All right, if those two are rubbed together, silk is going to wind up taking some of the electrons away, leaving it overall negative charged, and nylon positively charged. What charge does the polyurethane have if it is rubbed against wool? So polyurethane here, wool here. Big difference. Lower on the list, stronger hold on the electrons. It's going to take some of those from the wool. Now, if you wanted to rub, or if you wanted a rubber balloon, this guy right here, all right, to have a positive charge, you would have to rub it against what? Pretty much anything that is lower than it. These guys have it, all right, below here, have a stronger attraction. The guys below have a stronger attraction for the electrons and hold on the electrons than the rubber. So if it were rubbed with any of those, that would overall become negative. Hold your questions, bud, till the end.
Okay.
So what I was going to say next, there may be a question on your guys' test where they may say, okay, if you rub nylon and silk together or nylon and cotton together, which one would produce a greater charge? Which pair would produce a greater overall charge? So nylon and silk. Silk is a little bit below it on the list. So it's going to take, let's say out of 10 electrons, it may take 1 or 2 away from it out of every 10. Cotton further down on the list, right? A stronger pull for the electrons, take maybe, 4, 5 out of 10. So because of that, there would be a greater imbalance, therefore a greater difference in charge. So that's a question. Okay, so the ones pretty much, if they have a greater distance away from each other, they're going to have a greater overall charge on each other. All right, then we go to the back side. Going to the back side. Conductors are materials which electrons are able to move freely about. Examples, pretty much metals. Most metals are very, very good conductors, some better than others. Now you have something called an insulator. An insulator is a material through which electrons do not move freely about. They pretty much, once they get on there, they're kind of locked in place for the most part. They pretty much are localized in that specific region and where the charge was put. Metals are good conductors because they have free electrons. Now, it's super easy to put a static charge on an insulator because electrons can't move freely. They have a tendency to stay where they're put, which had to deal with that one of the questions from the sweater and balloon activity yesterday. Now, how do you get static electricity off an insulator? You have to pretty much ground it. Okay, so removing a static charge by providing a path to the ground. Electrons, okay, can move from a negatively charged object to the ground until it's neutral. Electrons can move up from the ground to the object to neutralize positive charges. So the Earth is considered to be an unlimited supply of electrons and a bottomless pit for depositing electrons. Now, there is an example, all right, that I want to talk about in a minute. So just remind me on that. Finishing off this little symbol here, basically a wire, and like this 1, 2, 3 is like the symbol for an object being grounded. All right, a path to the ground. To put a static charge on a conductor, you must isolate it from the ground, and by using an insulator to separate it. We don't really need to know the pith balls and whatnot, but pith balls and electroscope detect static charges. Both are made of a conductive material with an insulator around it to isolate the metal parts from the ground. So from that, I do briefly want to mention induction. So induction is a form of, is another form of charging. You have friction, which we've talked about. Conduction is where if you make contact with something, okay, the object's going to try and balance out charges. This is transferring a charge without touching. So the side of the object closest to the charged object would receive a charge opposite to that. And this is usually temporary. Remember, only electrons can move. Now, the drawings, not the greatest, but they produce like the idea. You have a neutral object here. You got 1, 2, 3, 4 positives, positive charge, 1, 2, 3, 4, negative charge. If you bring a positively charged rod near it, the electrons, for the most part, are going to move closer to that. Now, this drawing kind of is misleading because it looks like the protons jumped over to the other side. I made it like this because in the video that this goes along with, this is more so to just show the overall idea that the left side is now more negative, the right side is more positive. But there would still be protons, positive charge over here. So in this, you bring the charged rod near it, okay? Remember that a charged object can attract a neutral object. Neutral, all right? They would kind of move around here, and then because now of the imbalance, it would be drawn towards it. But if I don't touch it and move it away, it goes back to being neutral. Same idea with the negative charge rod. A negatively charged object brought near it, like charges want to repel. So the negatives kind of, we don't want to be here. They scoot to the other side. All right, but it's still now able to be attracted towards it because this left side is more positive. So conduction is the transfer of static charge by actual touching. The object receives a charge that is the same as the charging rod, and that charge is there permanent until something else happens where it's grounded to neutralize them. So if you have a negatively charged rod going near a neutral pith ball, some of the electrons, once they make contact, are going to wind up being transferred over, making the new object, right, or making the neutral pith ball negative as well, and the negative and negative, like charges repel. If it were for a positively charged rod, some of the electrons here would transfer over to try and balance the strong positive charge. So now both of them would wind up being, all right, have an imbalance of electrons. They both would wind up being positive, and like charges here still repel. Okay. And then I wanted to show, now these are in the notes that I posted today on conduction and induction on the classroom. Then, okay. So this was kind of like an answer to one of the questions yesterday again with the balloon and sweater activity. So what's going on if you put a balloon next to a charged balloon next to the wall and it sticks? What's going on? The balloon is charged by induction. The polar molecules on the wall, all right, charged by induction. So like they wind up turning essentially, right? The negative electrons, all right, kind of go a little bit further away from it, all right, or to the other side if you would want to think about it like that, leaving there to be a opposite charges here. This side is more positive. The balloon is negatively charged, so there is an attractive force there. Now they asked this question like, well, what should happen when an object is touched by a charged object? The object should take the charge of the other one, and then once it's made contact with it, it should bounce and repel off because it would have the same charge. But in the activity yesterday, you put the balloon, you rub the balloon on the sweater, you took some of the negatives away from it, and then you like put it around the middle, let go of it, and it drifted back towards the sweater, but you didn't see any of the negative charge go back on the sweater. So what kept that from happening? Well, the fact is that both of the materials are insulators. And in insulators, the charge doesn't spread out like it would on a metal sphere or conductor, like they'd move all around. So the conduction doesn't happen. They're both good insulators. And when two good insulators touch, it may be very difficult for the electrons to move from one object to the other. So conduction just doesn't happen. Okay. So now if I show this, it's a crappy drawing, but bear with me. Hopefully this makes sense. If I bring a negatively charged balloon and I bring it near a neutrally charged metal sphere, and the metal sphere neutrally charged, and we have to isolate it from the ground. So we're going to put some like kind of insulating material here. So if this thing is completely positively or neutrally charged, right? You got positive, negative, positive, negative, positive, negative, positive, negative, right? 4 and 4. Now, if a negatively charged object is brought near this but does not touch, what can happen, or what does happen? The electrons are the only ones that can move. The electrons are the only ones that move. So we would say that this electron is going to scoot over here. So he's now gone. And then this one maybe scoots over here. And now he's gone. All right, so now this side, we would say overall, this side is more negatively charged, and this side is more positively charged. Makes sense. Good. So then what's going to happen? Oh, somebody stopped me. Somebody didn't stop me. What was wrong with this? That's a good. I made a mistake, but let's analyze this real quick. What mistake did I just make? What kind of charges attract each other? Opposite. I brought a negatively charged object here, and I was just saying that the negatives, all right, the negative charges slid over this way. Yeah, that should not happen. So these guys would actually yeet. These two over here would wind up going over away, farther away, making this side overall negatively charged. This side overall positively charged. Makes sense. Okay, that makes sense. Now, if you touch this side of the sphere, right, with your hand, with the finger, and you have a path from you to the ground, okay, there's going to be a transfer of electrons going on here. So if we just show here, okay, grounded symbol. So pretty much two things can happen. Electrons can either go in to try and neutralize something, or leave to try and neutralize something. There's pretty much two ways. Well, if I kind of just cover this side up, there's an imbalance here, correct? There's 1, 2, 3, 4 electrons. All right, and we have our 4 negative charge, 2 positive charge. So would more electrons want to come up to that, you think? Would that make sense? No, they're not attracted to a negative charge. They're kind of repelled. So what's actually going to happen is some of these electrons are going to leave in order to try and balance at least this side out. So if I wanted to balance this side out, how many electrons would leave? If I have 1, 2, 3, 4 negative and 1, 2 positive. 2 electrons would want to leave, all right, in this grounding process. And once they do that, well, now, okay, like right here, positive, negative, balanced, neutral, good. But now if I take my finger away from this, right, if I remove a path from the ground, well, now everything else is kind of, we're like not worried about it. And if we just look at that cylinder, we have 1, 2, 3, 4 positive charge, and now only, right, 2 negative charge. So overall, what is the overall charge on this object now? It would be positive. All right. Now, same concept here. If I were to take a positively charged object and move it towards a neutral cylinder, so we got 4 and 4. Now, are the electrons, are they going to jump? Are the electrons going to jump from the neutral sphere over to this positive charge? Are they going to completely jump and move over here? Can they do that without coming in contact? No. They would need a tremendous like imbalance, but right now this thing's neutral. If there was a hella amount of negative charge, okay, you can, if the charge is great enough, you can wind up getting that little, right, transfer, right, electric transfer there, or current, where you get the little static shock, and you can get that little, where it can jump through. But it is not going to happen here. Can the protons move at all? No. So the protons can't move. So what would happen is the electrons from this side would want to slide over in this direction. And if they do that, that would make this side overall negatively charged and make the right side over here positively charged. Okay. Now, if I did the same thing, if I touched it with my finger and I had a path providing it to provide a path to the ground, all right. When doing so, you can have basically electrons enter or leave in order to try and neutralize something. Right now, there's an excess positive charge on the right side. So, are electrons going to want to leave that? No, that wouldn't make sense. Opposites attract. So these electrons would actually wind up wanting to come in here to neutralize at least, this little spot here that we picked out. So 2 electrons would want to, let's say, come in, and if they do, then you get 1, 2. This little area here is now neutral. Positive, negative, positive, negative. Now, if I take my finger away, right, if I take it away from the sphere, and I break that path, and then move this guy away, all right, then what's going to happen is, on a conducting material here, the the negative charge guys will wind up spreading out. So we have 1, 2, 3, 4 positives. 1, 2, 3, 4, 5, 6 negative charge. So if you have more negative charge than positive, you are overall a negatively charged object. So you're going to wind up doing an activity, all right, today, guys, where you're essentially going to do that. Now I'm going to run through one of them with you in a second. So guys, once you click on the link that is on your stream on Google Classroom, all right, it's going to take you here. You can expand this to make it a little bit bigger, scroll down a little bit. You can't add your name in here. You're just going to hit the start button. Okay, it's going to have a couple different questions for you: apprentice, master, wizard, which includes all the questions from both apprentice and master. So if, let's just say, we started here with apprentice, I just want to show you this because I'm going to break you guys down into separate groups, separate rooms, and you guys are going to go through this together here. So I just want to show you how it's done. So you have a neutral metal sphere. A negatively charged balloon is brought near it. While, all right, the balloon is held near it, this sphere is touched. And then they want to know what is going to be the charge on the sphere after that. So if you look, you can view animation. It's brought near, it doesn't touch. You come, touch this, you move away, the balloon moves away. What is the overall charge on this guy? So down here on these options where it says tap to toggle through answer options, this is what you guys need to do. Okay, there's 8 options, and you have to select the right one on both of them in order to check your answer. And it will tell you just whether you're right or wrong, but it won't tell you which. Now I'm going to give you something here. What does not move? Protons. Protons do not move. So any of the options you see where the proton moves, that's automatically a hell no. Now, this is not going to, they're not going to have any, so only electron options pretty much are going to be ones we use. And since they never really come in contact over here, you're not going to show something like this where a negative, all right, charge, the electron jumps over into the other thing or goes from here onto the other object. There is no contact, so that can't happen. Okay, so we're pretty much left now with 2 of the options. Now, I made this mistake earlier, so we shouldn't do it again. Like charges do what? Repel. So you have a negative here. That means negative charges are going to want to go away from it, not towards it. So that's not going to be an option. We're looking for this, where the electron is going to want to get away. Now, once that happens, this side is going to become more negative. So by providing a path to the ground, just like I showed, okay, on our the little picture going on here. If this side, the right side, is more negative, it's going to want to try and neutralize itself. So some electrons are going to probably want to leave in order to balance that end out. So we're looking for this guy, which would then leave this sphere overall positively charged. And then you check your answer, data away. If not, it will tell you, nope, you got to try it again. Idea here, just because this is different than the balloon example that I had drawn, you have a pie tin, aluminum pie tin, whatever the hell, and you're putting it near a negatively charged board. So again, protons don't move. Electrons, are they going to move away from the negative charge here? Yeah, I don't even have to click any farther. They're going to move a little bit farther away. All right. No, these electrons from the board are not going to jump onto the plate. They're not going to move towards the negative charge. Okay, so this is going to be that option. So then the upper end is more negatively charged. So if I make contact with it, provide a path to the ground, some of that excess negative charge is going to wind up leaving to try and balance this guy out, leaving the tin positively charged. All right, so you guys, when I break it down into rooms, you guys will go through them and do those, and then the master questions is a little bit of an extra thinking. All right, so I'm going to have you guys do those, and I'm going to pop into the rooms and I'm going to check how you guys did with that. And then the homework will be posted. There's 7 questions, multiple choice. All right.